Hello, good day. Welcome back to Coding with Veryl. In today's video, I'm going to talk about embeddings and how that relates to the chunk size. And I'm trying to do it simple and illustrative, okay? So if you know my style, I go for trying to give you a simple illustration of what's going on so you can understand it. Not necessarily that's exactly how it is or, like you can be an expert. It just gives you a foundation on which you can build. So without further ado, let's jump right in. We talk about how when you use RAG, Retrieval Augmented Generation, your prompt is being augmented with data that comes out of a database and sent to the model, and of course the model processes it. The model is doing what it's usually do. The model doesn't know anything about the fact that how you're actually using a data extra data. All it sees is the one prompt star. We also look at how you create this database, which is our stack. What you did was you create embedding. And we're going to talk about what embedding is. Now that we know that our database contains embeddings, what are embeddings? Well, no offense, but we're going to start off like babies. And so imagine that I had 3 properties, and those are going to be red, green, and blue. And they can range in value from 0 to 100%. For these 3 properties, red, green, and blue, I want to use them as a way to express their presence in describing something. And for the thing that I want to describe, I really just want to say how much percent of red is in it, how much percent of green is in it, how much percent of blue is in it. That's what I want to say for anything I want to describe. With this information, I can create a color wheel. And my color wheel, you can see, I can say this is something here. Like if I want to say I'm picking this point on the color wheel, it's probably all red. There are no greens in it and no blues. But as I move up this way, I start having more and more green added to the point where I'm here at yellow. It's essentially 50% red, 50% green, and no blue, of course. And then if I keep going around, I'm having less and less red and more green. And of course, I still have no blue. As I keep going, I have no red. I have, of course, all green at this point. And then I start adding a little bit of blue. And so you get the idea. So white in the middle is essentially no red, no green, no blue. And black is all red, all green, all blue. But that's not shown here on this color wheel. Okay. So what does this have to do with embeddings? Let's say we have these phrases, Grand Canyon, Grand Prix, that sort of thing, right? Now I want to embed them. Well, essentially, like I said, let's think of embedding as just being able to express each one of these phrases as having a certain combination of red, green, and blue. Those are the only 3 properties I have for expressing any one of these. So I'm really trying to map each phrase onto this someplace on this color wheel. So maybe the Grand Canyon, it maps to that location. Grand Prix mapped here, and you get the idea. I map the other ones to respective locations. Now, because Grand Canyon start with grand, maybe, however, that combination of, it has some strong combination of red, and Grand Prix, therefore, also has some combination of red. And so it's closer to Grand Canyon. And you can see Grand Central also, because it has grand, it has some combination of red. And so it's a little bit closer also to the other 2. But Food Central, maybe Central start pushing it into the blue. And therefore, like Food Central is slightly more towards blue, and Food Court also sort of pull it down. Now, using my 3 properties, I figured out a way to give each one of these phrases some combination of each property. And the more similar phrases are, well, it means they should, in theory, if I do my embedding correctly, be somewhat close on the color wheel. And now you see that when I look for Grand Canyon, Grand Prix and Grand Central are sort of close by. If I look for Food Court, guess what? Food Central is close by. If I look for Grand Central, well, not only is Food Central close by to Grand Central, but so is also Grand Prairie, right? So this is how that similarity is being picked up, because the thing that you're embedding, or the chunks that you've created now, what we have here is our phrases. These are the chunks, right? And we're doing some manipulation on it to create an embedding, which is this thing that allows us to come up with a value to represent that chunk. So when we have a chunk, so the chunk is what we decide, how big we decide to break things up, our data. And then once we have a chunk, we create an embedding, which is some sort of operation that take that chunk and turn it into a value. And this value is something that we can use to be stored to represent that chunk. And therefore, when we later on look for that value, we can see other things that are close by. So it allows us to easily do things like similarity and clustering and so on. Let's say we turn those properties into vector, essentially, or array, if you like. I'm going to put each value that I have for each of these chunks after I do the embeddings. I'm going to put it into an array. And so for Grand Central and, all my other chunks, this is what I might map them to, right? I might say that Grand Central, I can say, have 100% red and no green and no blue. That's not exactly right, but let's just go with it. Grand Prairie have, some red, a lot of red, but a little bit of green and, blah, blah, blah. And it might not be exact. I'm not trying to say these are the exact thing. I'm just trying to give an illustration, and so on and so on, right? And you can see that as we move down to the bottom of the food court, we have more blue and, no green, for example. All right, so if you can understand this, if you don't understand this part, try rewatching the section again, and hopefully by rewatching it, you can get it. If you don't, sorry, I think at that point, just ask your LLM that you're already running to explain embeddings to you like a baby. Honestly, you can, not baby, do like a 10-year-old and you'll see. And so now that we have this, we can see that it doesn't work for just text only. Let's say I have these pictures, and these are pictures of Georgetown, Guyana. As you can see that if we take this image of the courthouse and we embed it, maybe let's just say we're taking the entire image, right? But whatever it is, we create a value for this image that's here. And then this other image, it results in a value here. And this other image results in a value here. But you can see, because these two images have some similarity, even though they're not the exact same image. If they were the exact image, they would have the same value. But because they're similar, their values somehow going to land in this multi-dimensional space, or on my color wheel in this case, with 3 different dimensions, if you like. They land somewhat close to each other. And so if I were to look for this picture and I said, find similar pictures to it, well, guess what? If my database has like other pictures that were embedded and their, embedding value was close to this one, then the database could then return those values that are close by. And that's where the similarity comes in. And so you see, it works for text, images, it can work for video, all that stuff. And that's why being able to have the correct chunk size is how it's going to be able to help you find something. So you can imagine in this image, if our chunk size were such that it picked up this steeple and then it picked up the clock and so on, it is then easier for it to find the similarity in this image, which also have the similar steeple or the same one, depending on how you see it, and the clock that is very similar, right? So it's easier to pick those up. Okay, so what does a embedding actually look like? So I said a chunk get turned into an embedding. The embedding is the numeric representation of that array that represents the chunk. So in the database, there's special database called vector databases because, well, it looks like an array, it's a vector. It gets stored in the database, the chunk with the vector. And so this is what an embedding vector look like. It's this floating point array with a ton of numbers. Now, they say I show like 7 numbers or something, but embeddings are going to have hundreds of numbers. And we'll see that regardless of what size you pick, the array size is going to be the same for that vector. So if you choose one word, it's going to give you the same length array as if you give it an entire paragraph or something like that. The size of the chunk matters in the similarity or what the value is produced, but it doesn't matter in terms of the length of the vector that's produced. Going back to our chunking now, if we have this text, which is some text I used the LLM to generate on my computer, I said, hey, generate a story about a rainy day, and this is what it's generate. And I'm not showing you this to see whether this makes sense or not. That's not the point. What I want to show you is if we decide to embed this entire text as a chunk, then we'll get some embedding vector that's just whatever length. Let's say it's 100 floating point value. I can also choose to say I want to embed by sentences. And so maybe the title is one sentence and then here are the other sentences. And so each one of them will get their own embedding vector. And again, it's still going to be 100 floating point values per vector. But now you can see how if there are sentences that are slightly similar, not only in this poem, this story, but in some other story, that they might land next to each other in this 100 dimension space that I can't envision. But through math, we can be able to pull up, find similar sentences and therefore pull up stories that might have some similarity. So that is the secret, is that the chunk size get converted into these vectors, and these vectors are multidimensional values. And due to an operation that can be performed, it's then easy to sort of find similarity because you can find, chunks that were indexed close to each other if you want to think of it that way. So if I go to my command line here, I'm in ep008 directory, and I'll just start a code here. And one of the things I showed you when we install Ollama, and I said that if you go to the RESTful endpoint for Ollama, you can just see that it's running. So I use this plugin for VS Code called REST Client. It allows me to create like a file and put these commands in it that I can run. So I'm not going to spend time going through that. Just look up REST Client if you're using VS plugin. If not, then use your command line. You can do curl on this, or if you're using HTTP IE, you can just simply replace the get and this sort of thing with HTTP IE. Just look up how to do this stuff from the command line. Literally type it in an LLM, in your LLM, and say, how do I do this in curl or HTTP IE? All right, so if I click this button, send, you can see that it comes back and says Ollama is running. Now I can get a list of models that I have. And if I do send here, you can see my models. This is all-minilm. This is a model that can be used for doing embedding. I also have another model for embedding, which is the one we used in Misty, which was nomic-embed-text. So that's somewhere down here. Anyway, it's in this list somewhere. But what I can do is, let me close this here. And so if I say that, I want to get some embeddings, what I can do is use the Ollama API, the embed API, and I can post a JSON document, which I can say, this is the model I want to use, which is all-minilm, and you can just pull that model if you want. And I could say I want the input or the text I want to embed is this. So in this case, I just embed a letter, which is the letter A. And so if I send that, you can see that the letter A results in this array here called embeddings. And you can see embedding is just an array of arrays. And in this case, since I only have one value that I sent, well, it's just one array. But you can see That's the multi-dimensional or multi-value vector / array that I told you about, right? And it's like 300 and something, values for that one letter. And so let's say I want to use another model. So nomic-embed-text, which is the one we use in MISTI, and I want to embed the exact same value A. These two models for embedding are not going to embed the same way, but they will embed the same value every time the same way. So let me say that again. So when I ask this model to embed A, I'm always going to get this array. When I ask this model to embed A, I'm always going to get this array. What I'm not going to get is the same value between models. So now that you have this value, now you can store this value along with the chunk, and that is what you store in a vector database. So again, Ollama hides all of this for us, so you don't have to do anything. Ollama is using a model to create the embeddings and then storing the chunks and the embedded value, right? So then here's the example. I create an array of values and I could send that to nomic-embed and I can say embed that. And now what we have is an array of embeddings. And so you can see embeddings and it goes on and on and on. And then you should see the first value here sometime. And then eventually, and nomic-embed is using like, I don't know, a couple of, the other model was using like 300 or 390 values per embedding, but nomic is using what, like 700 per embedding. So we should find the next one over at 14, somewhere about here, 1400 or something. We should see the next array. This is going to be the end of the second one, and there we go, and then the third one. All right, so once again, we don't really need to understand this because the vector database that stores this crazy long array per value, when you ask it for a string, it's going to get an embedding. It's going to go into the database and find other things that are similar, okay, or close by. So hopefully this gives you a little bit better understanding of how we go from being able to create a stack or a database of things that are important for us, whether it's text or images, whatever, and what happens behind the scene to make that data available when we search for it, that it can find similar things that then can be used by the LLM to then help us answer questions. I don't want to make this video too long, so hopefully you learned something. If you did, please thumbs up the video, leave comments. If you're new, please consider subscribing. I would love to have you. I'm trying to grow the channel, and you taking just a second to hit that subscribe button really does make a difference. If you're a returning subscriber, thank you so much. See you in the next video. Take care. Stay safe. Bye.